see, as Ariane said, I'm Feng, manager of the ISPCS Transportation Integration Office, and what my office does is for the 12 to 15 flights per year which come to the International Space Station, we provide integration services and also contract management for our CRS contracts. So we take the current fleet of 5 vehicles, being the Dragon, the Cygnus, Progress, Soyuz, and HTV, which launch on their 4, sometimes 5 different launch vehicles from the 3 different international partners with vehicles, and we help integrate them and resupply the space station. In the coming years, we're looking forward to adding the commercial crew vehicles within the next year or so, as you heard in the last panel, and then very soon after that, we'll have Sierra Nevada and the Dream Chaser coming up to ISS as well. So before we jump in with our panelists, I was just thinking back, and it hasn't been very long. The ISPCS, I believe, has been going on now for 12 years. Just 5 years ago, this week, as a matter of fact, the first CRS mission birthed to the International Space Station. So it was 5 years ago, Tuesday, and in that year, in 2012, a little bit over 400 kilograms of cargo was first delivered commercially to the International Space Station. In the intervening years, that's increased every single year. In 2016, we had a little bit over 11,000 kilograms. This year, we're on track for probably around 17,000 or so kilograms. So it's really grown over the years and just been a very exciting thing to watch. I also want to throw a shout out to Kathy Leaders, if she's still here. She was heading up this office, first established it, and she's done a fantastic job. Now, of course, she's gone on and leading in the commercial crew program. So joining me on the panel today, let's see, we've got Mr. Mark Sirangelo. Mark is the Corporate Vice President of Sierra Nevada Corporation Space Systems Business. We have Benji Reed. Benji is the SpaceX, well, you've already heard about Benji's current role as Mission Director for Commercial Crew Programs for SpaceX, but also he was a Senior Mission Manager for CRS as well prior to, so welcome. And of course, Frank DeMauro. Frank is the Vice President and General Manager of Orbital ATK's Advanced Programs Division in the Space Systems Group. So welcome to all 3, and I'll hand it off to Mark.
Well, thank you. Well, first I'd like to do a bit of a thank you and a shout out to Pat, if I could, wherever she's wandered off to. There you are. I was fortunate enough to be here 12 years ago when this started and to speak at that conference, Pat, and I think it has changed a little bit since then. But I wanted to thank you and your staff and the team behind us, and certainly Las Cruces in New Mexico, for allowing this event at a time where the commercial space industry was just a thought in most people's mind. We really have come a long way. And as you heard Vin talk about the fact that there are so many vehicles that are actually now flying or about to be flying, it's a testament to that. So thank you very much for all your efforts on this. You have that clicker? We've been moving quite rapidly on a number of different fronts for our vehicle, our cargo system, as well as the other work we're doing in space. It's quite a busy time for our company. Last year we did about 20 missions. We're launching something about every 3 weeks. So we know hardware, we know how hard it is, we know how hard it is to build. And this program, Dream Chaser, has been working now for almost 14 years since we first started. It was, and still is, inspired by the NASA program called the HL-20. And I'm very fortunate to have one of the people from that program, Carl, in the audience today. And his job is to make sure that he hits me with his cane as often as he can whenever I go off track. So Carl, thank you for representing so many of the people behind us, because really this is just a continuation of many years of hard work on lifting bodies and the design of lifting bodies. And we took this program and licensed it out of NASA in 2005 and have been working it since then. And are fortunate now to be in a place where we're actually moving and flying and testing. And one of the, as many of you know in this industry, you get these moments where you stop and you realize what you're doing is so extraordinarily special. Well, we are now flying out of the Edwards Air Force Base and what is now the Armstrong Flight Research Center in California. And we're out now doing flight testing on our full-scale vehicle, and that is going quite well. But we were fortunate enough that NASA decided to open up the historic shuttle hangar that's up in Edwards and allowed us to be hangared there. So this picture you see, which is not to scale on the 2, if you can imagine, but you can see the human on both sides. But it was really sort of an amazing moment to be able to tow our vehicle into a place where Enterprise did all its work. We're flying in the same place, same runway, same test center as Enterprise did. And we feel in many ways we're carrying that torch as well as the torch of the HL-20 and others before that. And it was so special that I had to issue a special order to my team that they were not allowed to sleep in the hangar because they, being the geeks that they are, they wanted to stay there with it and sort of experience this. And 40 years of progress in many ways and 40 years of continuity in many ways has really moved us forward to the next level. And this is just a brief video that gives you a sense of what we're looking at. And it's the beginning of what we're doing is called captive carry tests, and we're launching at dawn in Edwards. And it's one of those moments as someone who's been building a spaceship, you realize that cable better not break. But it is an amazing thing, and there are hundreds of people on our team and now over 30 different organizations who are partnered with us to make this work, and we're fortunate to have the best of the best behind us on it. We are moving forward, and what you see here is our depiction of our being able to approach the space station. We can dock and berth, which is, I think, a very good feature of the vehicle. We carry up about 5,000 kilograms of cargo. And in a unique system, the cargo module, which you see in the rear of the spacecraft, then gets loaded up and detaches and burns up. So we're actually able to do disposal of cargo, a significant amount. The primary vehicle then returns home. And as I like to say, we leave the station for breakfast and we're home on a runway for dinner. It's about 8 to 10 hours from the station to the ground. As many of you know, we can land on commercial runways. We take about the same runway as a 737. And to that point, and I know George is in the room smiling at me, yes, we will make sure we get all the paperwork done properly, George, before we do that. But it is something where a number of spaceports and airports around the country and around the world are beginning to look at how can we properly do this. So it's a neat feature of what we're able to do. And a lot of this is geared to the science aspect. The whole purpose of the space station is not just to take the images that we've all come to know and love, but to actually do real science. And to the extent of bringing that science home in a matter of hours to a runway at less than 2 Gs in a reusable vehicle is a way to preserve and expand the type of science we can do. And that's one of the biggest things that we try to do with this vehicle. We are also fortunate to be able to be doing this globally. And we have signed agreements now with 22 different space agencies around the world. And it is a global business. And a lot of this is we talk about is commercial. And the commercial is where does it come from? And we've viewed this from the very beginning as a vehicle that can be a vehicle for the world. As we own the vehicle and we operate it, NASA is one of our clients and certainly the biggest and most important one. But it is intended to go out and do other things for other organizations. And we recently, last week in Australia, signed agreements with both the extension of agreement with the DLR and a new agreement with the Canadian Space Agency to bring them on board as partners. And we have advanced at the same time. We made an announcement of our mission with the United Nations. And this mission is quite a unique mission where we'll be able to take up over 25 different countries on board the vehicle. And many of them are countries, emerging space countries, for the first time to space, as part of a dedicated laboratory vehicle, unrelated to NASA or the space station, independently operated to be able to do that. And the United Nations last week has announced the plan for how do these countries and universities begin looking at how they get on board this mission, which is slated to launch in 2021. And finally, as we move forward, this is a bit of a video depiction showing our Next Step 2 Gateway program, which, if we go back one, I don't know if the video will run or not. So maybe you guys can see if you can run the video, if it works. Well, maybe not. But anyway, we are fortunate enough to have been signed on as a prime contractor to design and build a prototype for the Gateway program. There we go. And this is a depiction of what that will look like. I know one of our partners, ILC, Dover, is in the room, and I'd like to thank you for your work on the inflatable habitat portion of this. And it is a fantastic program to be part of. And the contract is to build a full-scale ground prototype, which we're now working on. And what makes this sort of really special for us and for me is this is the 50th year anniversary of a pretty famous movie called 2001: A Space Odyssey. And if those of you have seen that movie, as I have, and I was inspired by it, one of the things you noticed in that movie was the first depiction of a commercial spaceship going to a commercial space station. And Arthur Clarke, who actually began writing that in 1948 as a short story, and then Stanley Kubrick, who turned it into a movie, never really, I mean, they imagined 50 years before we're doing what we're doing now, what's being done. And I think it's pretty special for our team and all the people that have been supportive of Sierra Nevada to be now thinking that we're both doing that. We're building a commercial space plane and a commercial space station. So those people from 50 and 60 years ago certainly had some vision, and we're finally now being able to execute it. So thank you very much.
Thanks. Benji?
All right. Hello again. As Ben mentioned, I'm here representing SpaceX, and although I'm Director of Commercial Crew, I did spend quite a bit of time as a mission manager in the cargo program. It's what I started with. In fact, when that first Dragon went to station, I think I was maybe 6 months on the job at SpaceX. So it's been a great time for me as well, watching the whole program grow up. So where do we stand today? The Commercial Resupply Services program for SpaceX, which of course started as the COTS program, where we developed Dragon and quite a bit of Falcon 9 for the purposes of the flights to station, has come a long way. We completed the 12th and final mission of the original CRS-1 contract just last month. And in total, we've delivered over 53,000 pounds of cargo to the ISS, exceeding the original 44,000 pound requirement. 38,000 pounds returned, continuing to make Dragon a key asset for station in our ability to return cargo and return science back. And we've continued to improve that capability with additional upgrades to Dragon in partnership with NASA, and also in terms of those timelines of how quickly we can bring the science home. And 2,000 pounds of unpressurized cargo was disposed of, so helping to clear the decks for new science and new experiments that are happening. And of course, we've extended the CRS-1 contract that's happened a while ago, so there are 8 more missions coming up on that contract. And then there's a minimum of 6 under the new CRS-2 contract that will be undertaken. And so we're very excited to continue this. Again, remembering the first demonstration missions and then the very first CRS-1, it's amazing to think that we're at this point in the game, and really just 5 years later. We talk again a lot about commercial space and what everybody here is working so hard to bring to the table, and that's a key part of it, right? We have to be rapid, we have to be reliable as a team, as an industry, and this is the sort of thing that we're excited to see happening. To come from the beginning to this point in 5 years is very exciting, I think, for all of us. And again, that's part of that whole thing I just talked about is reusability. As you all know, we've been working hard and successfully reusing Falcons. And this year, we were able to do our first reuse of a Dragon as well, which is very exciting. So we refurbished, launched, and recovered the Dragon that was originally flown under CRS-4 mission. I was hoping it would be the CRS-3 Dragon, which was my mission the first mission I managed, but it ended up being CRS-4. We refurbished that one and flew that as the CRS-11 mission earlier this year, again in a tight partnership with NASA for the whole process of how do you certify a new vehicle or a reflown vehicle for flight. And then we completed CRS-12, just came home in September, and that was the last new build of Dragon 1 cargo vehicles. And from here on out, they will all be flight-proven vehicles to go up on station. Overall, again, continuing the theme of reusability and reflight, and very much tied to CRS and the whole program and the commercial initiative that NASA brought to the table, and has been such a critical, fundamental partner of. Again, Falcon 9 was a huge part of that development, was jointly with NASA for the CRS program. And so where do we stand now with Falcon 9? We've had 42 successful launches and 18 landings. 15 of those launches this year alone, which now puts us at the same number as Russia. So we have the same number of launches as entire nations. And we may have as many as 5 more launches yet to go this year. We have a couple of fun little records that we've done. We've done 2 flights in 2 days, 3 flights in 12, and 4 flights in 32. Some of our little windows. Successful flight of the first flight proven F9. So we reflew an F9 in March of this year. We did it again in June, and yesterday was the 3rd flight proven Falcon to fly. So we're very excited about that. Falcon Heavy is coming online. All 3 cores have been individually static fired, and we're preparing for an integrated system static fire. And our Demo 1 launch is scheduled to come out of 39A later this year. Again, just kind of another graphic of looking at some of these things, but in terms of reusability, return is a key. We've had 18 successful landings, 11 on the drone ship, and 7 on land. 11 so far this year alone. And again, I mentioned we're looking for maybe as many as 5 more launches yet to go this year. And this is a graph that we recently put together, and I love to show. And I think it's telling just by itself. This is the U.S. commercial launch, the share of the market. So back in the early 80s, right, we were basically 100%, the United States with 100% of the commercial market. And you can see how that trend wound down. With the advent of Falcon 9, and again, very much part of the CRS program, you can see now how the U.S.'s launch market is driving. All right. That's it for our presentation. Thank you very much, and thank you again to CRS and NASA.
All right, thank you, Benji. Frank.
All right. All right, good afternoon. Great to be back here. I don't know if Pat's in the room, but I was here 2 years ago, almost on an exact same panel, except Josh was here for SpaceX. And I was invited back last year, but we had that OA5 mission. I couldn't, so I had to bail at the last minute. So I'm glad Pat gave me another shot and invited me back. So it's great to be at the ISPCS once again. So I'm going to talk a little bit about Cygnus and where we are, but I'm also going to talk about where we are as far as growing the Cygnus capabilities for hosting additional payloads, our growing science capability, and where we think that's going to head. So, like SpaceX, we developed Cygnus under the COT Space Act agreement. We were in the process of developing Antares on our own prior to that. And of course, we were awarded the first CRS-1 missions at the end of 2008, I think it was, right before Christmas. So far, we've successfully launched to the station 7 times. The Cygnus vehicle itself has continued to evolve into a more capable spacecraft. We originally started off flying what we call the standard Cygnus, which was a cargo module about 2/3 the size of what we now fly. We call the enhanced Cygnus. And we've grown our cargo carrying capability from the original missions of about 1,500 kilograms up to about 3,500 kilograms of cargo by increasing the volume by about 50%. So we've done a lot of work in optimizing that space and being able to carry as much cargo as we can for NASA. Quite frankly, one of the things that spurred us on to do that was as we moved from the standard Cygnus, which was supposed to fly on Orb 3, onto the enhanced on OA4, we wanted to take advantage of 2 things. One is the additional capability Antares was gaining by changing the engines to the RD-181. But also in the meantime, while they were doing that, we launched 2 missions at the time on the Atlas V. And so we wanted to take advantage of that lift capability. And so we worked closely with NASA and Thales Alenia Space in Italy on figuring out how we could pack more cargo in there. So far, that's been very successful, and we've launched the enhanced Cygnus now. This will be the 5th mission of that variant of Cygnus. The service modules are the brains of the spacecraft. That's the back end that has all the power, propulsion, and all the computing part of the spacecraft. That's the work we do in our Dulles, Virginia facility. That work began as part of the Space Act agreement, as I mentioned, and we've continued to build multiple vehicles at the same time throughout the CRS-1 contracts. We've been able to support missions pretty much as NASA has needed. The cargo module is built at our partner in Thales and Torino, Italy, and those two pieces never see each other until they get to the launch site. Right now, the OA-8 mission is at Wallops Flight Facility, going through its integration paces. The initial cargo has been loaded into the cargo module. The cargo module has been mated to the service module, and so at that point, we have a Cygnus, as we say. And so that Cygnus is now going through its integrated launch site testing, and eventually, not too long from now, we'll start loading the late load cargo, and eventually we'll put the final load cargo a couple of days before launch, and then we'll eventually get mated to Antares, roll out to the pad, and be ready to go. Right now, we're slated to launch on November 10th. That's a Friday morning at 8:03 a.m., so we're always excited about getting ready to go and delivering more cargo to the ISS. As an enlarged picture of the spacecraft, one of the things you can see about it is there is a lot of space on the outside of that spacecraft. Some on the service module, a lot more in the cargo module. And that's one of our themes, is that we're getting out there more and more, talking to companies that may want to fly missions to space on Cygnus as ride shares, as hosted payloads. We have flown a couple of hosted payloads so far. I'll talk about that in a second. But the systems we have, the power capability, the computer capability, and in fact, as we fly OA-9 next spring, we will be flying the next generation of our avionics, where we're increasing our capability to talk to hosted payloads, to give them more telemetry, more commanding capability, and more data storage capability. So we're looking forward to that coming online on the next mission. Just some pictures, because I just love showing the pictures. If you've been in the space business a lot, I've had the pleasure of launching a lot of spacecraft in my career, but Cygnus is the first one you actually get to see again. I'm sure you guys feel the same way about Dragon. It comes up to the space station, and you're holding your breath a little bit, but you're confident it's going to work, and there it is. Looks just like when you sent it up, and so that's really special. A couple of pictures there while we're grappled, and on the right, you can see us berthed with some Soyuz vehicles. I included the picture on the lower left because that is about a year and a half ago that both the kind of new at the time U.S. cargo vehicles were on the space station at the same time. It's just one of my favorite photos, and I'm sure has to be one of NASA's favorite photos.
It's on my screensaver.
Yeah, yeah, it's perfect. So that's a great one to see. So we do support ISS utilization as much as we can. Obviously, our primary path to that is by carrying science and experiments inside the cargo module that get delivered, get removed by the crew, and get moved into the space station for them to get those experiments to get completed by the astronauts on the station. But we've actually had a couple of different special experiments that we've used Cygnus as the launch pad, so to speak. We've flown a few missions now where we've deployed CubeSats directly off of Cygnus. After we've completed the primary mission, we'll fly away. We have an external deployer that's mounted on the side of the service module, and when we get into the right orbit, one time we've done below the ISS, but twice now we've gone above the ISS and deployed CubeSats for NASA on behalf of NanoRacks. We're going to do that again on OA-8. So far, each of the missions we've deployed 4 CubeSats. This one we're going to do up to 14. So that's a pretty special thing for the team to see. Also, we've flown the Sapphire experiment 3 times. This is an experiment that came out of NASA Glenn to study combustion and fire propagation in the microgravity environment. So it flies up as cargo inside the cargo module. It stays there during our stay, and then eventually when we fly away, then we will actually light some material on fire in the cargo module. It's an oxygen environment, it's air. It burns for 20 minutes or so. It is controlled by our team, but it's witnessed by the NASA Glenn team, and then we eventually downlink lots and lots of data for them to study, video data, other sensor data. I think the last mission we downlinked 50 gigabytes of data for the NASA Glenn team. So I think so far all 3 of those experiments have been very successful. They learned each time and then implemented minor changes for the later mission. So that's been very exciting. So that's sort of where we are. Now we're looking for where we're going to go. Right now, we've grown the capabilities for powered mid-deck lockers that we can fly on the spacecraft to up to 6. We'll talk in a minute about where we want to go from there. We can vary the pressure inside the cargo module, should that be of interest to someone that wants to fly a payload. I've talked about our ability to accommodate external payloads with the CubeSats. We can do a lot more of that. If you look on the bottom 2 pictures there, you can see depictions of places on the outside of the cargo module where we could mount hardware, mount experiments, and we could interface those experiments directly into our avionics inside the service module, and then be able to control those experiments for potential customers. I do want to point out the pictures in the middle there of the NanoRacks deployment. No solar array was injured as part of that experiment. It does look like it goes pretty close. It doesn't. All the deployments have been very successful. So we're looking to the future. Obviously, our main focus is providing our customer what they've asked us to provide as part of this contract. Deliver pressurized cargo to the International Space Station, take away disposal cargo that they no longer want there. We've delivered about 35,000 pounds of cargo so far. We've taken away roughly 20,000 pounds. We'll be delivering another 7,400 pounds of cargo on this next mission. So that's our primary mission, but we've got a lot of capability that we can offer folks out there that might want to fly additional payloads. We have the variant of Cygnus that can be used as a science module, dedicated science module, where we can put double-digit powered mid-deck lockers to fly around. We can stay up in orbit for quite some time, over a year, give the experiments a unique, very clean microgravity environment. We can also fly up to the ISS, take on payloads, fly away for however long, and eventually return to the ISS and deliver those payloads back to the crew for their experimentation. So there's a lot of things out there we can do. We consider ourselves open for business for commercial use of Cygnus. We will continue to focus on our customer's primary mission, but then we want to use Cygnus for more than just cargo. And that's it.
Great. Thank you, Frank. Let's see, just to sort of underscore what several of these gentlemen have said, we on the space station, we're in full utilization period now. We're running hundreds of experiments and investigations on every single expedition, every single increment. And the commercial resupply vehicles, really since the first vehicles through now, as an ascending arc up through CRS-2, are really increasing a lot their payload accommodations capabilities. We're looking to extend the U.S. lab. We've essentially run out of research room on board the space station, so we're examining concepts with our commercial providers to essentially extend the U.S. lab into their vehicles for the periods of time that they're attached to the station, and a lot of other very interesting things, as you heard Frank and as well as Benji talk about. So as I mentioned, ISS is open for business, as is, as you mentioned, Cygnus and Dragon, and soon to be Dream Chaser as well. Let's see, with that, we have several questions. And Ariane, I'm not sure if you have some as well. I can start out with one here, and it's really for anybody. Let's see, what elements of your CRS architecture are transportable beyond LEO to cislunar space, to the Martian system, or even have applications back here on Earth?
Well, from our perspective, the gateway program that I had shown the image of is actually built around our cargo module, which is the same module that we'll be taking up to the space station. So we are going to have a multiple use version of that. And as we build the gateway program, which is intended to go beyond Earth orbit and lunar orbits somewhere else, or potentially someday at Mars orbit, we will be utilizing many of the same elements of what we do for the cargo vehicle.
Yeah, certainly for us as well. I mean, the development of, again, Dragon and Falcon as a major part of the CRS program, and a lot of the underlying technologies, certainly the Dragon capsule itself has potential outside of LEO and within lots of LEO business development, and also much of the fundamental architecture and technology of Falcon.
Yeah, I think with Cygnus, there's a couple of different avenues. One, we think extending the capability for the logistics services out to cislunar space is a natural evolution the Cygnus vehicle, whatever variations that modifications we'll have to make to it. Those are things we're studying right now. One of the things we're studying as part of our Next Step 2 contract with NASA is how to create a variant of Cygnus that could be an initial habitation module out in cislunar space, and an augmentation module to help not only for a place for crew to go as a temporary way station, but also a place where they can conduct experimentation. Maybe they can house some supplies, things like that. And then we think there's parts of our architecture which, again, with certain modifications that we're studying, can be part of the gateway, part of the power propulsion element that NASA's looking at as part of the deep space gateway architecture. So we think there's a natural evolution of things, and we've got teams working on that not only as part of the Next Step program, but as part of our internally funded research.
All right, let's see. What will it take to develop a robust and self-sustaining commercial market in LEO? Transportation, but also other aspects.
From our side, I think it requires the ability to go beyond NASA and go beyond even the U.S. government. In order for this to work, I think all of us have some level of interest in reusability. That's certainly a key element of it. But it has to be more than that. We have been so fortunate to have NASA create this public-private partnership model and to be part of that, to have the opportunity then to own the vehicles and own the infrastructure. But it now becomes incumbent on us not only to meet our missions for NASA and for the U.S. government, but then to look at it and say, how do we extend it out? In our sense, our vehicle is a multi-use vehicle. It can carry cargo. It can be a human transport vehicle. It is going to be a freestanding laboratory, and it also can do servicing in space. We don't think any one of those markets on its own is going to be enough to sustain a vehicle program. But being able to be versatile and be able to have multiple markets from the same architecture, no different than an airline company, Boeing or Airbus, has multiple versions of their planes, and that's how they move to profitability. We're employing the same model in space.
Okay, thanks, Mark.
Yeah.
Benji?
Yeah, absolutely. And I think we talked about it a little before in the other panel as well. I think John mentioned it quite a bit, but it was, destination is really key. Having to provide transportation services, you have to have lots of destinations. And so I think that is key. It's exciting to see all of the different players that are looking out there to do space station development work that's ongoing in from a number of companies, a number of fields, or a number of groups, and then different applications as well. And talking about also looking at that expanding customer base, particularly when it comes to crew flights. You look at who are all the different folks that can go, but then they're also going to need supplies, right? I mean, one of the reasons we're supplying station is to provide what's needed to keep the crew there, as well as all of the science. So they go hand in hand. I think the development of human space travel is very much a critical part of developing the overall business.
Mm-hmm. All right, thank you.
Yeah, I was going to summarize by saying you need enough places to go that need the logistics services you're offering, and if that exists, I think the robust case is there.
And I think going beyond that, there's a level of cooperation that is probably going to happen between companies. We have used SpaceX rockets for our program. We're part of the Cygnus program in developing the berthing mechanism. But it's more than just transportation. I'd like to say, from our perspective, transportation is like having an iPad. Without the apps and without the purpose, it doesn't have a reality to it. So you have to build the other infrastructure. One part of our company is doing how do we grow food in space, and to be able to sustain life, to sustain development. And one has to look at the entire infrastructure, not just the transportation piece, in order for this to work.
Mm-hmm. All right. Let's see.
Time for audience questions here.
Very good.
Mark, I'll address you with the first one. There are people in the audience that are interested in hearing a bit more about your development program, but the upcoming tests. So you showed us a video of the captive carry. What's the next schedule for the next test, drop test, and then first flight?
Sure. We are, as you saw in the depiction, that is a full-size, full-scale vehicle that's in flight test right now. There's a series of tests that leads up to its first, this version, which is a Block 2 version, first autonomous test. We're expecting that to happen before the end of the year. It is a fully autonomous vehicle. So it's not ground controlled, it's not as a UAV. So the systems on board are all the orbital systems, orbital flight systems, orbital control systems. So while the vehicle is going through atmospheric test, which is the same thing that Enterprise did, we're also simultaneously testing what we need to do to go to orbit. Concurrent with that going on, we're very quickly working through the design program. We passed PDR this year. We're months away from CDR, and that program, with NASA's help, is going quite well. And the third piece of the stool for us is the build of the orbital vehicles, which we have started. We have a number of partners who are doing that. The primary structure of the first orbital vehicles have been built, and now about 30 different companies are working on doing the subsystems that are necessary for that. We've built and have opened up our new integration facility in Colorado to be able to take all these and bring them together. And just last month, I announced that we purchased the first of what will be we hope to be many launches, and have begun the process of building the rockets. We expect, working with NASA, to be flying in 2020, and that's our goal right now, and everything is being pointed towards that end goal.
You mentioned commercial customers. You, of course, announced your international partnership with the UN. Do you have a time frame for that? Where is that going to slot in with respect to your NASA flights?
Yeah, one of the really great things about our vehicle design is that being composite and being in design, a lot of the effort goes into building the tooling and the first vehicle. Doing subsequent vehicles becomes not easy. Nothing is easy in our industry, but becomes much more straightforward, where we can envision a fleet of vehicles that are reusable, that have different purposes. So we're actively out marketing it right now for different missions. The first non-NASA mission is now slated for 2021. And we expect it to be a free-form standing laboratory version, which is now currently under design. And because the fleet is versatile in that regard, we're not tied to the space station, nor are we tied to doing transportation. We intend to do missions that are repair, construction, and science, freestanding science.
Mm-hmm. Well, so you all have mentioned other customers. Again, expanding beyond the NASA customer. What lead time are you anticipating for these commercial payloads? Are we talking months, years? And how do we scale that down for some of these customers, potential customers in the audience? Frank, I'll let you answer that one first.
Yeah, so it's a little complicated. So it will partly depend on the customer side and where they are in their development, what interfaces they need us to accommodate. If they're standard interfaces that already exist on the spacecraft, it's pretty much you need to find the space to put it. You need to run some wires, and it's ready to go. We were able to integrate the NanoRacks deployers on a pretty short time scale. If there's more to be developed, then we need to look at that and see how much modifications we'll need to make, and also on the customer side. I think the second part is how much of what the customer wants to fly will they ask us to help in terms of getting through the NASA safety process. That does take some time, and we're very willing to help with that. And I think the third part of it is, obviously, our primary mission is NASA. So to the extent that we either have excess capability because of the launch vehicle or some room, that you might not know until a little bit later in the game. So we're out there talking to customers to say, if we've got existing interfaces, we could fly something within a few months to the space station. From there, it could maybe be up to a year. But we don't, unless it's some very out of the ordinary interface, it shouldn't be anything longer than a year.
And are you doing your own direct sales, or are you also leveraging NanoRacks as well?
We're doing direct sales. Certainly, we have a very good relationship with NanoRacks. We'll take anybody that wants to fly with us. Yeah.
Sounds good. Benji?
Yeah, I hopefully see this kind of market open up more and more in the next few years, and as soon as possible. I think that Mark mentioned it too, there's such an opportunity for partnership and collaboration, right? The ultimate goal to open up, as I like to say, the space age is going to be lots of competition, lots of partnership, and lots of folks working together. So you mentioned, how do some of the folks in this room and whatnot, how do they get a ride? How do they get there? Whatever it is that they want to send, how do they get it up there? And I think that, again, a lot of that's going to come through collaboration. It's going to come through, rideshare opportunities or those sorts of things. And so we see that as well. once there starts to be the beginning of more destinations, more use cases coming together, then we can all come together and find ways to, I think, get everybody flying.
Mark, do you want to add to that?
I think the other thing besides having a vehicle that has multiple uses is to do multiple missions at the same time, to use your time in space as productively and wisely as you can. That reduces a lot of cost for people. For example, we can take up about 1,500 kilograms of satellites externally on a vehicle on our mission. And that can come in, and is intended to come in any form, 3 500-kilo satellites, or a bunch of smaller satellites, or a bunch of nanosatellites. And to be able to do that while on missions at the same time allows us to provide not only access to people perhaps on a cost basis that doesn't exist or isn't easy, but it provides us the ability to then take the effort that we're putting into the mission and to spread it out. So the idea here is to look at the system as an entire system, and while that might have a point destination, what else can we do within that realm without affecting the primary customer? And because we do return home and effectively bring everything back home, if something doesn't work inside the vehicle, we can bring it home and fix it and bring it back up again, which again changes the thought process for a lot of people.
Great. Question, well, I'd like to hear from all the panelists, but especially would like to hear from Ven in terms of how has, what are some of the lessons learned from the first CRS program, and how have those been rolled into CRS2, and how you're executing on that from the NASA side, of course, from Orbital and SpaceX, but also, Mark, I'd like to hear from you. You've been in this for a while as well. What do you see improvements?
Sure, and there's certainly been a lot. So I'll go back maybe 10 years ago, and I had some involvement in the very early selection of the original vendors. And at that time, the shuttle had retired. We were transitioning from a return and replace philosophy for ORUs and resupply of space station to a build and burn, because we just didn't know if industry building complex spacecraft and new launch vehicles could actually build things that could return. So, shuttle, of course, retired in 2011. Subsequently, SpaceX and Orbital both came online, produced their own spacecraft, produced their own launch vehicles, proved that industry could do all this stuff on a firm fixed price basis and provide a lot of capability. So since that time, we've sort of established that initial capability, and we've sort of walked capability up the line in a deliberate manner to enhance both total capacity that can be carried, reliability, as well as payload accommodations. And you'll see that this increase in capability all the way through the CRS2 procurement, and then we're working on all those vehicles now. The vendors are working very hard on those vehicles now. But you'll see the number of powered mid-decks, number of external accommodations, the total up mass per launch, as well as reliability, all increasing over time. So that's part of a very deliberate, conscious set of decisions that we've been trying to make on our side.
Mark, how has it been in integrating some of these new needs?
It's interesting. I think we all share that there's a big technical challenge. There's always a big schedule challenge, and to be able to manage a program of these sizes. We had a really interesting, unique challenge that someday I think I'm going to write about that came as a result of the positive aspect of this public-private partnership. One of the aspects of the contract was that we fully negotiated the contract as part of the proposal process. So on the day that I received a phone call at 8:15 in the morning, 8:16 in the morning, we were under contract effectively to get going. From a standing stop to a multi-billion-dollar program within an hour. And because this is also a schedule-driven program, any time or any days that were not used productively went against schedule. And of all the things that I've had to manage, and I think we have had to manage in the company, imagining hundreds of new hires and new buildings and new facilities and 30 partnerships and all these, you couldn't actually sign up. You couldn't hire people because we didn't know from one day to the next whether or not we would be chosen. My associates here had programs going on at the time, so it was a very unique feature for us that we had to manage through. And to get all that infrastructure virtually overnight moving forward, and to do it in a way that was both quality-driven and being able to meet schedule, and at the same time overcome this. So there's a very different part of this public-private partnership kind of model that I don't think anyone could have anticipated what the challenge was behind it. And we've managed through it, but it was certainly one with a lot of lessons.
Benji, perspectives on CRS-2 versus the original program?
Sure. I think that it's a lot of opportunity for sort of a stair step or constant increase, small steps at a time. From the beginning, starting from COTS into CRS-1, CRS-2, CRS-3 flights, the missions specifically. CRS-3, for example, was actually a significant step up in capability. That was actually that we added a fair amount of capability to the Dragon to accommodate more NASA-powered payloads, among other things. And that was the first mission to carry up science payloads in the trunk. And so sort of, as Vin mentioned, there's been a certain sort of steady increase of capability. At the same time, a steady increase in application of lessons learned that have happened. But it's true that when you get to, I'm not sure if it's so much of the new contract as much for us, as much as the opportunity to have a new vehicle that we proposed as part of that CRS-2 contract. So bringing on the new Dragon line that will also have the Crew Dragon, it also will be the new Cargo Dragon. And so that opportunity presented itself, and again, in collaboration with NASA, because they provided us both the contract for the crew and for that cargo opportunity, so we could use that new Dragon for both those lines or for both those applications. And that was a great opportunity then to go back and say, okay, kind of what's a major step increase, a large step increase from CRS-1 into CRS-2. And so a lot of the same things, some of the things I talked about earlier, are very much applicable in the CRS-2 realm. A lot of the fabrication, the factory level, but the design for fabrication, the design for test, which you always are trying to optimize and do your best at, but a lot of times you don't really know until you get there.
Right.
And some of that's in fundamental structure, some of that's in fundamental design aspects. And so with a new, an updated Dragon vehicle, we were able to roll a lot of those in. And allow for a much more efficient and streamlined path. I think the other thing that, again, has sort of been steadily increasing, but we also have the opportunity of within the new CRS-2 contract, is the amount of back and forth that you do both with NASA, but also internally, the number of people that need to be involved in managing a program. The whole thing, if you do it right, can become much more efficient, significantly more efficient. And that's where we've gotten to. When we were first developing the whole notion of this partnership and how to operate CRS programs under COTS and then into the first CRS flights, we had a lot more people who were, needed to work that, and because part of it, you were developing processes, you were developing, management, operations, again, factory level, building, testing, all of these things, you were developing them as you went along. And so a lot of those are now in place, so you don't need people to actually develop all of that. But also, as you go along, you learn a lot of efficiency. So the numbers of folks that are needed, both on the NASA side and on the SpaceX side, to manage those programs and to execute them, manage but also execute from at every level, has been able to be greatly reduced, which again is just another step towards that commercialization capability. Because you're ultimately driving down then your costs and allowing for access to space in a much more efficient manner, because you can drive down the number of people that have to be involved all along the way.
Great. Frank?
Yeah, so a couple of things. I think when we initially started the development of the spacecraft with the initial set of requirements, I think it's fair to say, and I mean this as a positive then, that there were some aspects where NASA maybe wasn't even sure what they wanted out of these vehicles. And as the developments went along, we learned together what was really important and maybe what wasn't as important. But we came up with a vehicle, in our case Cygnus, that worked really well and did what it was supposed to do at the time. I think when you cracked open the RFP and the requirements for CRS-2, it was clear that NASA had thought through, okay, this is really where we want to head with this thing. From our point of view, a lot more science capability than maybe we had in the previous versions. The ability for us to carry rodents, I know SpaceX has for a while, we'll have that capability coming up. More powered mid-deck lockers. The ability to load cargo later and be able to refresh it later. is important in NASA. So there's a capability that we've been able to add. So those types of things, clearly from a science point of view, this is mostly about utilization and being able to get the space station to be used for as its main purpose of doing that science. I think one of the things Benji just hit on, though, in terms of getting the vehicles flying, he's absolutely right. I think when I look at the number of hours it took to put those first few vehicles together to what we can do it for now, and not sacrifice safety and not sacrifice reliability and mission success, I think it really is a testament to the commercial model of having NASA involved. We learn from each other, and then you get to a point where we can do this very efficiently and work through our respective processes very well. So
wonderful. Frank, I'm going to stick with you for a moment here. So big news of the last couple of weeks has been Northrop's acquisition of Orbital ATK.
I hadn't heard about that.
Really? Oh, okay. Well, newsflash, everybody. How does that change? Does it affect your Cygnus program? How does it open up the realm of possibilities for your program and your product?
Well, I think so. In the very near term, doesn't affect it at all because we haven't been acquired yet, right? The lawyers are doing paperwork, and there'll be folks all over the government figuring out if this is a good idea. And on the assumption that they do, and we close on the acquisition sometime in the first half of next year, we fully expect, and Northrop Grumman has said, that they'll be operating Orbital ATK as a fourth sector and letting us do our thing. We are confident, I'm certainly confident, that one of the hopefully many reasons Northrop thought this was a good idea is because of the team we have that's doing Cygnus, that's doing our other space vehicle programs, that we have a really strong cadre of space people that they want to keep letting us do what we're doing. So I think in the immediate term, no change. I think in the medium term, no change. I think they'll realize that we know how to do this. Let us keep doing this. And so we've wanted to make sure our customers understand we have no intention of changing. I think in the longer term, where this could really be a positive is if there are additional resources that Northrop Grumman can bring to bear. There may be other investments they might be willing to make in addition to some of the things we're looking at. So we would certainly see that as a positive. So what we're looking at it as we were a desirable acquisition. Northrop took that step, and we think it'll be positive in the end.
Great. So I think one of the things that Orbital ATK has done very well was adapting to not having Antares for a while. Now you've got it back online, but potentially you also have your next-gen launcher. What is your game plan for what happens if the next-gen launcher goes forward, or what happens if the next-gen launcher doesn't go forward? Does Antares continue to be your workhorse? Are you potentially chatting with ULA about other opportunities to use Atlas and others? How do you look at your ride to space?
Sure. So right now, OA8 is going to be Antares. We expect all of our remaining missions on the CRS-1 contract to be on Antares. And then looking ahead to CRS-2, certainly NASA has a say in that. We did offer multiple variants of the spacecraft. We've baselined that they would all fly on Antares. If NASA would like something different, we'll certainly respond to our customers' needs and do that. In terms of the NGL infusion, that's something we'll look at further down the road. There's certainly a couple of hurdles before that becomes the larger reality that we hope it does become. Certainly would give us options looking forward. But right now, we have the team focused that it's going to be Antares all the way out.
Wonderful. I'm going to end on this question. I think a nice inspirational question for the end of the conference is important. I think we all have been inspired by Apollo and shuttle and space programs before us. How are each of your organizations, NASA included, by way of this program and others, inspiring the next generation to get involved?
Wow, let's see. I think, I've seen so much excitement just from, I go and speak on occasion, just the university excitement of engineers and other fields coming out now is certainly much higher than it was more recent history after announcement of retirement of the shuttle and cancellation of Constellation and so forth. I think the amount of innovation and the cycle time for folks to be able to come out of school, work a project, bring it to a flight or operational environment so quickly is in and of itself causing, it's a cycle that's feeding upon itself. So I think that NASA, when we look at our portfolio of projects, we look at more some of the traditional ways of doing them, as well as more some of these cutting edge sort of ways where it's like, okay, we're going to have a higher risk tolerance for cargo, for instance. We're going to have maybe a similar old traditional risk tolerance for human flights. We're sort of opening up our palette of options, so to speak. And I think that especially here in the commercial arena, industry has really just picked up the torch and is running with it.
Mark?
From our perspective, there are many ways, but there are 4 that I think we're really working quite significantly. The first is that we've tripled the size of our internship program in the last few years, and now are working with over a dozen universities to provide incoming people to do that. But it's not just as much to have the internships. We've actually hired almost 150 people over the years who have come out of internships to permanent jobs. And the second thing is when they come in, they work in a mentor-mentee relationship. So they're not just given lower level work to do, they're actually working alongside somebody who's doing sophisticated second tier work, which we think is quite useful. The third thing for us is that we have a very significant part of our business is out to small, disadvantaged and new companies. About 20% or so of the work that we do is outsourced, that we outsourced is to that group. And we are giving opportunities to companies who are getting to be the next generation, not just with their people, but with their technologies behind it. And I think lastly are looking at unique missions like our United Nations mission, which is going to take 25 countries and universities and young people who have never gone to space. And that came out of the inspiration to say there's a lot of smart people in the world. And if we can provide hope to some young group of people who are working at a university in a country that's never been to space before, those people, that might be the biggest thing that they get to do within their year or within their life to get to go to space. And if we can inspire that many young people around the world, both here in the United States and throughout the countries we work with, then I think that the next generation is going to at least have the opportunity to not only do what we do, but hopefully bury it and do so much better.
Great. Benji?
I think that it's all about having big, audacious goals, right? Really just, you have to stay audacious. And as we all know, SpaceX was founded on the premise of making life multiplanetary and just opening up this exciting new time that we can all be a part of. And I think that just you have to maintain that focus and stay clear about where we're going and what we're doing here. And you feel that energy, and Mark was talking about 2001, which is an awesome movie and a great book. 2010 is also a great book. I love that one. And I think we have to stay inspired ourselves, right? I watch science fiction all the time, and I read books, and we do these things, and we need to go out and do that. And so in programs like internship programs, which we have a lot of, we hire a lot of folks right out of school. Promoting something that Ven mentioned, like fast turn, the ability to actually see what you do in action is so important. And it's also a critical part of what makes commercial and what will make commercial space. It's not long, drawn-out programs. It's fast, bam, let's get going, let's get something happening quickly. So keeping ourselves inspired so that we can then show other people that there is a way to do things quickly, and then keeping those great, big, audacious goals out there. I think that's key.
Frank?
Yeah, I think so. A couple of things. I think very much like Mark and Benji, we have a very robust engineering intern program where the interns are doing real work. We have engineers who have done software testing from Cygnus, and then they can come in and sit in the console as we're flying the mission. So that's extremely inspiring. We've really redoubled our efforts to replenish the younger generation within the company. We've hired hundreds of fresh outs. I absolutely adore that. I think it's great to see the youth filling the halls. There's an excitement there and an exuberance, and I don't mind being the old guy in the kitchen anymore. That's okay. I learn a lot. The second thing is, when Orbital first got into business in the early 80s, one of the main focuses of the company was to bring the benefits of space down to Earth and to provide lower cost access to space for smaller companies and startups. Well, now we have transformed that as an industry, all of us, that we now give access to space to students who build CubeSats in high schools that now can come to a launch. We have one on OA8, but I'm sure you guys do the same thing, where students will be able to see their CubeSat. It'll get lofted in the Cygnus and eventually get deployed out to space station. That is a tremendous tool of inspiration. And the last thing, I'll make it a little personal. You know, we do a good job, I'm sure these guys do too, of opening up our doors to the community and making sure they understand what we do. My youngest daughter, almost 19, she was all set to go to the fashion industry. And after a couple of times coming into our facility and watching Cygnus birth to the ISS, she said, you know what? That's what I want to do. And now she's a freshman aerospace engineering student at Arizona State University. And so she is, you know, she caught the bug. And I think it's, quite frankly, incumbent on all of us to spread that bug around and get kids excited, because there's nothing like it.
Wonderful. Excellent. Gentlemen, thank you so much for your time. A round of applause for our panel here. Thank you.